Assalamualaikum, we are from group 2 and our group have chosen the topic of number system. So I'm Ahmad Khairi Abid and I'm going to talk about the number system, it is a convention to represent a number system that specifies any kind of numbers or letters. So they have four common types, which is binary, decimal, octal, and hexadecimal. In binary, they represent with only two symbols or digits, which is 1 and 0. 1 is because when the low voltage, the computer will recognize it as 0, and the other one, which is the number 1, uh, this is recognized when the computer receive a high voltage. This also means that it has a base of 2. So going on to decimal. Decimal, they have 10 base, which is from 0 to 9 like we normally use. That means that it has all the numerical quantities. So moving on to octal. Octal, unlike decimal, they have 8 numbers from 0 to 1, 2, 3 until 7. But because it is an octal, the numbers could not exceed 8. So when they exceed 8, 8 in octal is 1 0. So the last one, which is the hexadecimal. Hexadecimal consists of 60 symbols from 0 to 9 and A to F. A to F is A is equivalent to 10, B 11, C until F, and so on, which is F is the final, which is 16. So on the last part here, this is a little comparison. You could see here from for example, decimal in number 11. So when converted into binary, it will become 1011. In octal, it will be translated as 13, while in hexadecimal, it will be shown as D. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amar Hazik and I am going to explain how to convert from binary to decimal, octal, and hexadecimal. So the first thing is binary to decimal. So basically we are just going to take the most right number in the decimal and then we are going to multiply it by 2 to the power of x, where x is starting from 0. So for example here we can see this one is 1001, where 2 to the power of 0, and then this one times with 2 to the power of 1, and so on. And the end result, we get 9, where every number is being added up. So next we're going to move to binary to octal. So this one we do the exact same thing as previous one, but before we start to do anything, we divide it into groups, where each group has three numbers in it. So here we have, after we've done separating into groups, and then we did the same thing with the previous one, and the end result is that we just combine the first part and the second part together. Now binary to hexadecimal is also pretty simple. It's the same thing as the previous one, which is the binary to octal, but instead of 3 in a group, we do 4 in a group. So here is the example, and when we get more than 10, we just need to convert it to the respective hexadecimal, which is, in this case, 13 is actually D. So we just convert 13 to D, and now we have 8D. So that is all for me. Now let's move on to the next one.
Assalamualaikum warahmatullahi wabarakatuh. My name is Irfan Coin bin Abdul Muhaimin, metric number 2116843, and I will be presenting on decimal number system conversion to binary, octal, and hexadecimal. So let's move on to the first one, which is binary. Binary is base 2, so we're converting a number from base 10 to base 2. Therefore, we need to divide the number by 2. So in this example, we have 9. So 9 divided by 2 is 4, and then we want to collect the remainder. So the remainder is 1. And then 4 divided by 2 is 2, so the remainder is 0. 2 divided by 2 is 1, so the remainder is 0. And then last but not least, 1 divided by 2 is 0, which is the remainder 1. And then we will compile the remainders from bottom to top, which is 1001, and that will be our final answer. Therefore, 9 base 10 is equivalent to 1001 in base 2. So now let's move on to octal. So octal is base 8. Therefore, we're converting base 10 to base 8, so we have to divide it by 8. So this is an example, we have 66. So 66 divided by 8 is equal to 8, and then the remainder is 2. And then 8 divided by 8 is 1, remainder is 0. And last but not least, 1 divided by 8 is 0, so the remainder is 1. And then we will collect the remainder from bottom to top. which is 102. Therefore, 66 base 10 is equal to 102 in base 8. Last but not least, hexadecimal. Hexadecimal is base 16, so we're dividing the number by 16. So in this example, we have 1,567. We divide that by 16, we will get 97, remainder of 15. 97 divided by 16 is 6, and then last but not least, 6 divided by 16 is 0. So the remainders we can see is 6, 1, and 15. However, 15 is not in hexadecimal, so we must convert it from the table on the right. So 15 is F. Therefore, the final answer should be 61F. So 1567 in base 10 is equal to 61F in base 16.
Assalamualaikum, I am Tasmia Rahman. I'll gonna convert from octal to other number system. So first of all, we can have decimal number system. The base number of octal number system is 8 and the base number of decimal number system is 10. For this conversion, I choose octal number 541. For this conversion, we need to into with the base number and the power of the numbers position, which is 2 and then 1 and then 0. So ultimately the power will gradually decrease from left to right. In this way, we can have the decimal number 353. After that, I will show the conversion from octal to binary. For this conversion, I tried to show this in two steps. The first step is from octal to decimal and the second step decimal to binary. For this conversion, again I choose the number 541 octal to decimal, which is 353 I did before. After this, from decimal to binary, we have to divide 3 till when the result will be 0, and then we will choose the remainder as the binary number system and it will go down to up. So in this way we can have the binary number 1011000001. After this we can have hexadecimal number system. The base of hexadecimal number system is 16. Again, I tried to do this in two steps. First of all, octal to binary and then binary to hexadecimal. From octal to binary, which is 1011000001, I did it before on the previous slide. After this, we can have the binary number and we gonna convert it to decimal. So we will have 1010110 and 001. So first of all, this one is equivalent to hexadecimal 1 and then 0110, which is equivalent to hexadecimal 6, and 001, which is equivalent to hexadecimal 1. So at the end, the number is 161 in hexadecimal. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zikri. Today I will show you how to convert from hexadecimal to binary, octal and also decimal. So first of all, we are going to see hexadecimal to decimal first. That is conversion from base 16 to base 10 number. So for, the example below is F19 base 16 to decimal. So how to convert is we are going to multiply each of these hex value by 16 and we're going to power it by 0 and increase the power by 1 according to each hex value. So we'll get 3840 plus 16 plus 9 and add all of this and we will get 3865 base 10, and that is our decimal number. Okay, for the second part is hexadecimal to binary, that is conversion from base 16 to base 2. There are two steps for hexadecimal to binary. That is, the first step is we are going to convert hexadecimal to decimal first, and after that we are going to convert the decimal number that we obtained to binary number. So the first step is same as before. So F90 base 16 is equal to 3865 base 10 using the same method before. So the second step is we are going to divide the number by 2 because binary using base 2 as their number. Okay, so 3865 base 2, we are going to get 1932 plus 1 remainder, and the remainder we are going to take note. Okay, we are going to repeat the process like before. That is, but we are going to take 1932, divide it by 2, and we get 966 plus 0, and the remainder we are going to take note also. So repeat the process until you get 0 for the quotient, and after that, for to read the binary number, we are going to look at the remainder number and read from the bottom to top, and we are going to get 1110000110001 base 2. Okay, for the last part is you are going to convert hexadecimal to octal number, that is from base 16 to base 8. So there are two steps for hexadecimal to octal number conversion that is the same as hexadecimal to binary. The first step is we are going to convert hexadecimal to decimal number, and the second step we are going to convert decimal to octal number by division. So the first step is same as before, we will get 3865, and the second step, rather we divide it by 2, we are going to divide the decimal number by 8 because octal using base 8 for their number system. So 3865 we are going to divide by 8, and we will get 483 plus 1 remainder, and the remainder we are going to take note. So repeat the process for 83, divide by 8, we are going to get 60 plus 3 remainder. The remainder also we are going to take note, and repeat the process until we will get 0. And after that, to read the octal value, we are going to read the remainder value from the bottom to top. Then we're going to get the answer for octal value, that is 7431 base 8. Okay, we have to do a C++ program for our system, that is number system conversion. So the program can convert any number system to another number system, such as binary to decimal, octal to hexadecimal, and so on. So let me show you how to use the program. Okay, so for number system conversion, we have an option from 1 to 12. You can choose any option that you want. Let's say if you want to convert binary to octal, you can press number 2 for your choice, and the program will ask you to give an input for binary number. So let's say we put 1011, and the system will calculate the octal number, that is 13. Okay, so if you want to continue the program, you just need to press 1, and the system will reset back. Okay, and I will show you another example, that is hexadecimal to octal. Okay, for hexadecimal to octal, according to the option is number 12, so we're going to enter choice 12, and we're going to enter the number in hexadecimal form. So I will put F19, and the program will give you the result for octal number, that is 7431. So after that, if you want to end the program, you just press 0, and the program will end. So that's all from us. Thank you for listening for our presentation. Assalamualaikum warahmatullahi wabarakatuh.